Continuing with your 2.1 notes, we're on 2.1b, how are waves classified? So transverse waves. These are waves in which the particles vibrate in an up and down motion. So for example, light waves are an example of transverse waves. So you can see in this video here that is moving up and down. It creates like an S shape. So a good way you can remember the difference between transverse and longitudinal is that transverse has two S's in it, and the wave moves kind of like an S. So remember to write down what's in red. This is just another picture of a transverse wave. The next lesson, 2.1c, we'll get into labeling it, but this is what a transverse wave looks like. All right, so longitudinal waves. Waves in which the particles vibrate back and forth in compressional pulses. So for example, sound waves. So you can see here in this video, we have these compressions, and this is how this wave travels back and forth, which is different from the transverse wave. So remember to write down what's in red. All right, so this is just a little video showing you the difference between them, comparing them. So you've got your transverse here, that remember goes like up and down, kind of makes a sideways S, and then longitudinal makes these compressions, and the compressions move. All right, so waves can also be classified on based off if they need a medium or don't need a medium to travel. So a mechanical wave, they need a medium in order to travel. Mechanical waves can either be transverse or longitudinal. So mechanical waves need a medium, and they can either be the transverse or the longitudinal wave. In some examples, you got sound, water, rope, earthquakes, tsunami waves. Go ahead and write down what's in red. And then we have electromagnetic waves, which these do not need a medium to travel. And electromagnetic waves are always transverse waves. So electromagnetic waves are always transverse waves.